You see that these are the notes for 5.5 on our double and our half angle formulas. Now, let me start over. You're going to again need to memorize these formulas, but they really just come from our sum formulas. Instead of using u and v, we just have two u's because the angles are the same. So you can get by using just your sum formula, but it's better to memorize these just to kind of get out of the way. So to start this, we're going to do the same way as we did before. We're going to start with example 1. It says, given sine of u is equal to 3/5 and u is between 0 and pi over 2. So u is in the first quadrant. So I'm going to draw a picture of it in the first quadrant. So this is u. Sine is 3/5. So that means my opposite side is 3, my hypotenuse is 5. Using the Pythagorean theorem, I know that my adjacent side then is going to be 4. So now let's find the sine of 2u. Now sine of 2u is actually pretty easy because we only have one formula to use. And so let's just do it right here. So the sine of 2u equals 2 times the sine of u times the cosine of u. Well, I already know what sine of u is. They gave that to me, and that was 3/5. And this is where my triangle comes in. The cosine of u is 4/5. Now just multiply them together. Our 2 is actually 2 over 1, so it's 2 times 3 times 4, and that's going to be 24 over 25. So the sine of 2u is 24 over 25. Okay, now let's do the cosine. That's how fast it was. Now the cosine of 2u. Now we have options with cosine. We can use cosine squared u minus sine squared u, or we have 1 minus 2u squared, or we have 2 cosine squared u minus 1. So we have 3 options. The one you choose is based upon which one you're comfortable with. I'm kind of comfortable with all 3, and they gave me the sine to start with. So why not use the one that has sine in it? And only sine. That way I don't run the risk of having make a mistake in my calculations of my triangle. So this one I'm going to use is 1 minus 2 sine squared u. So it's 1 minus 2 times, well, my sine of u was 3/5 squared. So that's going to be 1 minus 2 times 9/25. Well, that's 1 minus 18/25. Common denominator is 25. And I get 25 over 25 minus 18 over 25. And that's going to give me 7 over 25. And let me kind of make this a little bit bigger so it's easier to see. Okay. That is my cosine of my double angle. Now to find tangent of the double angle, we have 2 options. We can do 2 times the tangent of u over 1 minus tangent squared. But then we have to figure out what tangent is, and we can do that from our triangle. But here's the cool thing. We also have another option. Well, tangent is sine of 2u over the cosine of 2u. And don't I already know what sine and cosine are? Well, sine was 24 over 25. Cosine of 2u was 7 over 25. Well, both of these have the same denominator. And when that happens, remember we can kill our fraction by crossing off our denominator, and we're left with just 24 over 7. And so there's the tangent of 2u. Okay, so that's example 1. Let's go on to example 2. Same thing, same idea. I know that the cosine, so this is example 2, the cosine of theta equals negative 7/9. Now we can use u or theta, it's kind of the same thing, it's just the name of an angle. And that our theta is between 0 and pi. Well, if our cosine is negative, it means it's got to be in the second quadrant, so I'm going to make my triangle in the second quadrant. So this is negative 7, and this is 9. So to find my my opposite side here, it's going to be the square root of 81 minus 49. Square root of 81 minus 49 is 32. Simplify that is 4 root 2. So that side's 4 root 2. Now let's apply our rules. Okay, so to find the sine of 2 theta, it's 2 sine theta times cosine theta. Well, that's 2 times the sine of theta is 4 root 2 over 9 times the cosine, which is negative 7/9. Multiply our numerators together, and I'm going to get 2 times 4 is 8, times negative 7 is negative 56, root 2 over 9 times 9 is 81. All right, so there's my sine. And I'm going to put a little big red box around this for me. All right, let's do cosine. Cosine of 2, ooh, that's a bad 2. Again, I'm going to use the information that was given to me. And this kind of makes it easier because sine has that square root in it, and I really don't want to use the square root if I can avoid it. So cosine was given to me, and I have a formula for cosine, which was 2 times the cosine squared of theta minus 1. So that's going to be 2 times negative 7/9 squared minus 1. So that's 2 times 49 81st minus 1. Well, that's 98 minus 80 over 81 minus 1. Common denominator again. And that gives me 17 over 81. All right, there's my cosine. Put a box around that one. Oh, that's not what I wanted. I wanted this. Okay, there's my box. Now let's do our tangent. And again, the same thing is, the tangent of 2 theta would just be my sine of 2 theta over the cosine of 2 theta. Well, the sine of 2 theta is negative 56 root 2 over 81. The cosine of 2 theta was 17 over 81. Denominators are the same. I'm going to cross them out, and I'm left with negative 56 root 2 over 17. And there is my tangent of 2 theta. Okay, so that's example 2. Okay, on to example 3. This time we're going to be solving using our double angle formulas. Okay. Oop, that's wrong. All right. I want to solve 2 cosine of x plus sine of 2x equals 0. All right, to solve this, I want to get rid of that double angle. And so it's easy. Sine of 2x, we only have one option. If it was cosine, we'd have to kind of look to see what we have. If we have a cosine in our other part of our equation, we probably want to just use the one that has cosine. We want to kind of think about those ones a little bit. But for this one, it's 2 cosine of x plus 2 sine x cosine x equals 0. I just did a straight substitution. Now to solve this, if I look at this equation, I notice they both have a cosine and they both have a 2. So I'm going to factor out that 2 cosine of x. And then it gives me 1 plus sine of x equals 0. 0 product property. 2 cosine x equals 0. And 1 minus the sine, or 1 plus the sine of x, equals 0. Solving, I get the cosine of x equals 0. And cosine of x equals 0, if I do my arc, I know that cosine is 0 at, ooh, that's awful looking. Let me clean that up. At pi over 2 and at 3 pi over 2. So that tells me that now if we look at the other equation, we end up with sine of x equals negative 1. Well, where sine is equal to negative 1 also happens to be at 3 pi over 2. So these two solutions are the same. So it's going to make it really easy to write our final solution. So based upon where cosine of x is equal to 0, I know that x has to be equal to pi over 2 plus or minus, and the distance between these is just pi n. So that's going to include all of our solutions. Okay, on to example 4. We want to verify an identity. So this is example 4. We want to verify sine of theta minus the cosine of theta squared, the quantity squared, equals 1 minus sine of 2 theta. So looking at the left side, if I multiply this out, I'm going to get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta, and that's going to equal our 1 minus sine of 2 theta. Now if you notice in here, I see a positive sine squared theta and a positive cosine squared theta. So this cosine squared theta plus this sine squared theta equals a 1. So now I have 1 minus 2 sine theta cosine theta equals, and I'm trying to get that again to equal 1 minus the sine of 2 theta. Well, if I look at this right here is my double angle formula for sine. So I'm just going to substitute that in. And now both sides match. And that's example 4. Okay, on to example 5. Example 5 says we want to reduce the sine of 3x. Well, I could rewrite the sine of 3x as the sine of 2x plus 1x. Now, using our sum formula for sine, it's the sine of the first angle, so sine of 2x, cosine of the second angle, so the cosine of x, plus the cosine of 2x times the sine of x. Alright, now I'm going to leave this cosine of 2x. I'm just going to kind of leave it alone. I'm going to highlight it. Just leave it alone for right now. Kind of make that a little bit lighter. See if I can do that. There we go. So let me undo that. I'm going to actually do it like this. So I'm just going to highlight it a little bit. Now I know that the sine of 2x is the sine 2 times the sine of x cosine of x. That's going to be times the cosine of x plus, and I'm going to leave that as a cosine of 2x for right now, sine of x. Simplify the first part and I get 2 sine x cosine squared x plus the cosine of 2x sine x. Now, I want to get rid of the cosines. So, first thing I do, to finish simplifying, I want to end up with just sine. So, in the first part, the cosine squared, I could rewrite that as 1 minus the sine squared of x plus, well now I have 1 as well for cosine of 2x, my double angle, and that would be 1 minus 2 sine squared x times the sine of x. That doesn't look good. Distribute, and I get 2 sine x minus 2 sine cubed x plus the sine of x minus 2 sine of cubed x. Combine like terms, and I get 3 sine x minus 4 sine cubed x. Okay? Alright, so we've broken it down using our formulas, and that's what we have. So that is example number 5. Let's move on to example 6. Now example 6 is one of our double angles. Now with the double angles, we're not going to worry about that plus and minus right away. So example 6 says, oh, did it again, I'm sorry about that. Example 6 says I have the cosine, given the cosine of theta is 5 over 13, and that pi is less than or equal to theta is less than or equal to 3 pi, or 2 pi. So that's telling us where theta is. Now cosine's positive here, so I need to draw a triangle where cosine is positive. It's very similar to things that we've done in the past. So cosine is positive in quadrants 1 and 4, but my restriction says I can only go from pi, from pi to 2 pi. So I have to go from 180 to 360. That's the only place I can go. Well, that leaves me in the fourth quadrant, so I'm going to go down here. So there's my theta. So this is 5, and this is 13. Using Pythagorean theorem, I can find the opposite side, and that's going to be 12. Now this is a negative 12 because that's where my sine is. Now, this is where we figure out this, whether we have our half angles are going to be positive or negative. So my theta has to be between pi is equal to theta and 2 pi. So if I'm looking for pi over 2, I'm going to divide this whole thing by 2. So that tells me that pi over 2, or my half angle, is going to be between pi over 2 is less than or equal to theta over 2, or less than or equal to pi. So now my half angle is going to be in quadrant 2. Now let's find the sine, the half angle of our sine. So the sine of pi over 2, or theta over 2, I'm sorry, is going to equal the square root of 1 minus the cosine of theta all over 2. Now, our signs out here are either plus or minus. Looking at where my half angle is, my half angle is in, hold on here, my half angle is in this quadrant right here. So, based upon what quadrant I know that sine is positive, so I can actually just get rid of this negative sign down here. Now I just fill in the blanks and solve it. 1 minus the cosine from my triangle, my cosine was 5 over 13. I'm going to put 5 over 13 divided by 2, and now just simplify it. Common denominator on top is 13. So it's going to be 13 minus 5 over 13, and that's all over 2. So that's going to be the square root of 8 over 26, because you're going to multiply your two denominators together. And let me kind of fix my square root here. Now to simplify it, excuse me, you can reduce your fraction right now, and you're going to get 4 over 13. So you can now take the square root of 4 over the square root of 13. Square root of 4 is 2 over the square root of 13. Rationalize your denominator, and you get 2 root 13 over 13. So there's my half angle for sine. Let's do cosine. Same thing. Now we're still in that second quadrant, and so the cosine of theta over 2 is going to be, this time it's going to be negative, because cosine is negative in the second quadrant. And it's going to be 1 plus cosine of theta all over 2. And now just substitute our value in. The cosine of theta is 5 over 13. So it's going to be 1 plus 5 over 13 divided by 2. Kind of the same steps as we did before. Common denominator is 13. So it becomes 13 plus 5 over 13 all over 2. And that becomes a square root of 18 over 26. And again, I'm going to clean up my square root here. You can reduce your fraction, and you could get the square root of (9 over 13). Well, the square root of 9 is 3, and all of this is negative. I keep forgetting the negative here. So it's negative 3 over root 13. Rationalize your denominator, and that becomes negative 3 root 13 over 13. So there's sine and cosine. Tangent's easy. Tangent is just the sine of the half angle over the cosine of the half angle. Or we could use 1 minus the cosine of theta over the sine of theta. I think since we've already calculated the other two, for tangent it's just easier to do it this way. So that's going to be the sine of theta over 2 and over the cosine of theta over 2. Well, the sine of theta over 2 was just 2 root 13 over 13. The cosine of theta over 2 was negative 3 root 13 over 13. We can cross off the 13s, and now that's going to give me negative 2 root 13 over 3 root 13. 13s are going to cross. I just get negative 2/3. There's my final result. Okay, so that's example 6. Let's move on to example 7. Example 7 is not going to take us but just a couple of minutes. And we're just going to calculate the sine of 7 pi over 6, or 7 pi over 8. Well, looking at that, I could do a sum and difference. But if I had to use a half angle, I could see that the sine of 7 pi over 4 times 1/2 would give me the 7 pi over 8 that I want. So my theta is the 7 pi over 4. My theta over 2 is my 7 pi over 8. And what quadrant is 7 pi over 8 in? Well, that's in the second quadrant. It's way over here. It's a little bit more down here. All right, so sine is positive there. So now let's find the sine of 7 pi over 8 is going to equal positive square root of 1 minus the cosine of theta over 2. And that's going to be the square root of 1 minus, well, the cosine of 7 pi over 4, because remember that's our theta, is negative root 2, or excuse me, it's positive root 2, I'm sorry about that. It's root 2 over 2. All over, still 2. I'm not making my square roots big enough here. Simplify it. Common denominator top is going to be 2, so it's 2 minus root 2 over, multiply your denominator, so it's going to be 4. Simplify it. I can't do anything on top, so it just becomes 2 minus root 2. But I do know that the square root of 4 is 2. Okay? There's our final example. We've done 7 examples dealing with double and half angles. If you have any questions, please make sure you come to class.